All right, so this would be lesson 2 for kinematics. Okay, so let's start talking about velocity and speed. We've already talked about it a little bit. So you have average velocity, and this is going to be called v bar. So it's just a v with a bar on top, and it is the change in displacement over a time interval. And just think about that for a second for velocity. You have to cover a certain amount of distance in a certain amount of time. So jot that in. Cover certain amount of distance in certain amount of time. And you create this ratio, delta D divided by delta T. Certain amount of distance in a certain amount of time. And if you were to do this, let's say you had some constant velocity like this. So this is D, this is T. Okay, if you have a linear dt graph, it doesn't have to be linear, but if it is, then your velocity is constant, and you can calculate that velocity by doing some delta t, some delta d, and we call that slope. And there's the equation for the slope of that line. And this is known as average velocity. Okay, so hopefully this is clear. We've talked about this a few times. Okay, average speed, however, take a look at this 2 slides. This one's average velocity. Okay, average velocity. Now this one is average speed. Okay, so this one depends on distance. So speed is connected to distance, where on the last one, velocity is connected to displacement. So please make those connections for yourself. And if you look at the formula now, it would be the exact same thing for a graph, except it would be distance versus time, not displacement versus time. Okay, it's the exact same mathematically, just one is a vector and one is not. Okay, so this one would be your scalar average speed. That would be a scalar. The last one is this one's your vector. Okay, so velocity, vector, look at the v bar. This one's speed, scalar, just v. Depends on distance, not displacement. Okay, and then this word, this is a key word that you need to know. Uniform motion, constant speed. Those two things are interchangeable. Uniform motion, constant speed. In other words, acceleration is 0. It's not accelerating. The speed is remaining the same. Okay, let's take a look. A sprinter runs the 100-meter. This person is traveling north, then turns around and runs 135 meters south. Okay? All right. If it takes the runner 32 seconds, find average speed and average velocity. So, problem-solving skill number 1, draw a picture. That vector represents 100 meters north. Then what happens? Turns around and runs 135 meters south. How you guys feel about that picture? Pretty good? And remember, that's one dimension. You go up and then you go down. I just draw them beside each other for clarity. So, good. That would be the first one. Average speed is going to be distance divided by time, which would be 100 plus 135 in how many seconds? 32 seconds. So that's the speed. You've gone 235 meters in 32 seconds. 7.3 meters per second. How come I haven't put a direction on there? Good, because it's distance and speed. Good. So let's try the other one. Average velocity. And why did I only go to 2 decimal places? Good, because we got sig digs right here. Good. Only 2 significant digits. Okay, average velocity this time is v bar, and that will be displacement divided by time. Now, when you go to add these 2 vectors, remember, you have to be mindful of direction. So you have 100, which is positive, plus 135, which is negative, all over your 32 seconds. Any questions about that? Is that okay? Okay, so the displacement is 35 down. So I got a negative 35 divided by 32. And I got a negative 1.09375 or something like this. So to write this, I would go... Am I in the way? It's all there. Sorry, maybe it showed up late. So 1.1 meters per second south. That would be the final answer. 2 sig digs and a direction. Because it came out negative, I can attach south to the final answer. No, that's it. That's it. Any questions about that example? Okay, you'll have ones just like this in your workbook to practice. Okay, next one. There's some terminology you might not be aware of. You guys know what this is? Particle of light. Okay? So this is more for physics 30, photons, but this is a particle of light, sure, and this is the speed that we're going to attach to the photon. Okay? This is the universal speed limit. You'll never have anything travel faster than that. Okay? That's 300 million meters in 1 second. It's ridiculously fast. Okay? So if you ever have a question in my class involving some form of electromagnetic radiation, EMR, electromagnetic radiation, so we're talking about radio waves, microwaves, infrared, light, regular light, visible light that we can all see, X-rays, gamma rays, they will all travel with this speed, and you can call that speed c, 3.00 times 10 to the 8 meters per second. It gets its own letter, c, as it's the universal constant. So how long does it take to travel from the Earth to the Sun? I guess this is a photon maybe that's coming from the Sun and hitting the Earth. That would be the Have you guys ever looked up in the sky recently, especially with the smoke coming from the forest fires from BC, and you see that the sun is a bright orange? Or even like a deep red? Have you guys seen that? Most of the time, on a nice blue sky with no clouds and no smoke and no haze, if you look straight up and the sun is up at the top of the sky, is it orange? No. What color is it? It's a bright white. Good. But when it sets, usually if it's setting, you look at the setting sun, what color is it? It's more orangey. Okay, so some of the photons aren't reaching your eye, they're being scattered out. It's the blue ones that are scattered out. That's why the sky is blue. And what all that's left that reach your eye is a mixture of photons that you interpret as orange and red. So that's pretty interesting. This question is not as interesting. It's just a constant velocity equation, which you can solve very simply. And we have here, what's the formula for constant velocity? V equals d over t. What are we trying to solve for? How long? So then we want t up here, right? So v would have to switch places, d over v. The distance they're giving us is 1.49 times 10 to the 11, and this is 3 times 10 to the 8. The units, you can see here, the meters will cancel, and then the divide second will come up to the top. The second, when you divide by a divide, it'll come to the top. And of course, if you recall, you need to use second comma the enter exponent on your calculator to finish this off. Second comma, that replaces the times 10. Then you just type the 11. So in the calculator, I got 1.49 E11, 3E8, and that will solve it for you. Okay, so about 496.6 seconds. Do you guys know how long it takes the sun's light to reach Earth? You might know this. It's usually a fun fact most people know. How many minutes does it take for the sun's light to get to Earth? 8 minutes? Some people just know that, right? Okay, 496.6 divided by 60. Divide that by 60 seconds in each minute, you get 8.3 minutes. So if the sun blew up, we wouldn't know for 8 minutes. If this...
Well, we won't be alive then, so let's enjoy now.
Yeah, you... The sun is not going to blow up. It's just a saying. Okay, only one more to go. And tomorrow's class will start with homework. Okay, but you're going to get a head start on it tonight. And tomorrow's class will start with homework. Okay, let's finish this one more. Okay, a little birdie flies north. Okay, now when you read this, it goes north for at a certain speed for a certain amount of time. So this is a V and this is a T. What could you get out of that?
A distance.
Good. You have a certain velocity, a certain time, so from that you could calculate a distance. That's the type of thinking you have to have. In physics, I don't want you to read the entire problem and then start thinking about what to do. As you read a sentence, think to yourself, okay, what could I do with that? Keep going. Now it's tired, so it slows down to 4.5 meters per second. Okay, it's slowed down. Okay. it now travels at this speed for 2 more minutes. Oh, now I got a new speed and a different, or another time. Could I get another distance or another displacement? Yes. Finally, it turns around. That's important. It turns around. My friend at the back who's new to the class, please stop talking. Thank you. The other direction at 6 meters per second for 3 minutes. So you have 3 velocities and 3 times. What can you calculate? 3 displacements. So it wants us to create a position time graph. We can do that tomorrow when we have more time. I'm just going to draw some vectors. .5 meters per second. For how many seconds? 2 minutes, so that would be 120 seconds. So from that, I can get 1 displacement. What do we know d is equal to? Quickly. D is equal to Vt. Okay, that's got to be quick for you guys. 7.5 times 120. Okay, 900 meters. Now he slows down, but we have to ignore that acceleration. We just don't have the skills for that yet. So you just want to ignore the acceleration, and now you have a different speed, v2, 4.5 meters per second, for another 2 minutes. So that would be another 120 seconds. So what's the second displacement? Quickly, vt, 4.5 times 120, 540. Now, because you're a strong reader, the next vector is drawn which way? South. Now, I didn't know it was originally going north. I just picked a direction, and then I just have to go the opposite direction. So 6 meters per second. This time for 3 minutes. So that is how many seconds? 180. Okay, 6 times 180. You get displacement 3 of 1,080 meters. Okay, so D1 and D2 are both north, but D3 is south. Okay. Average velocity. You have to use displacement. What is the displacement? 900 plus 540 take away 1080. Okay? 900 plus 540 take away 1080. Why did I take away? Turns around, good. The result is 360 positive. And what time length was that? 120 plus 120 plus 180? 420 seconds? So 36 over 42, 0.86. How many sig digs do I got? 2? From the, yeah, 2 sig digs. So 0.86. And this is a velocity, so meters per second, in my case, north, or right, or positive, whatever you've decided. And then the speed, this one will use d over t. So it's the exact same calculation, except instead of subtracting 1,080, I will add it. Good. So 540 plus 900 plus 1080 divided by the same amount of time, 420, and I get exactly 6 meters per second. So 2520 in 426 meters per second. Do I need a direction on that one? No.